Hi, my name's Adam. I'm a fourth year computer science student at Keble, and I'm going to talk a little bit about functional programming. This is a topic that's covered in the first year of the course, and it continues throughout, but it's a type of programming most people haven't seen before they come to university. So I thought I'd give you a little bit of a run through of the basics so that if you're interested, you might go away and look at it a bit more yourself. Let's consider the function f of x equals 3x plus 2, which takes x as an input and outputs 3x plus 2. So f of 0 is 2, f of 1 is 5, and f of 2 is 8, and so on. The aim in functional programming is to write programs using functions a bit like this. So this is how that same function would be written in Haskell. The first line is the type of the function. It takes an int and outputs an int. The second line is actually how that function is computed. Note the similarity between the Haskell definition and the mathematical definition. While there are many other data types in Haskell, for this video we'll use only int and list of int. In functional programming, the input to a function could also be a function itself. These are called high-order functions. Here we have an example of one, twice. Twice takes a function and an int, and applies that function twice on that int. Let's have a look at a simple example. Double simply takes an int and returns double its value. Twice double 1 is 4, because double 1 is 2 and double 2 is 4. Twice double 15 is 60, because double 15 is 30 and double 30 is 60. If you're feeling confident, have a go at twice of twice double 10. I mentioned earlier the list. A list can either be empty, have one single element, have multiple elements, or even be infinite. The important function to be aware of is the colon. The colon prepends an element to a list. For example, here 2 was added to the start of this list using a colon. When we read this, we read the colon as cons. Functions can have a list as either an input or an output. For example, sum here adds together all the values in a list. As you can see, sum of 1, 2, 3, 4, 5 is indeed 15. But you may notice that the function sum has been defined twice. This is because we want to do something different with an empty list compared to what we want to do with a list that has elements. The method used here is called pattern matching. There is either an empty list, in which case we use the first function, or the list has elements, in which case we use the second. You may also notice that this function is recursive. It calls itself. Here we have a similar but more complex function map. This brings together all of the elements of functional programming we've covered so far. Map is a high-order function, meaning it takes a function as an argument, and it also takes a list as an argument. What map does is it then builds a new list by applying that function to each element individually, and then using cons, as we saw before, to concatenate all of those elements into one new list. If you have a go at programming them, you might notice that sum and map are quite similar in the way that they work. They both take an element from the head of the list, apply themselves to what remains of the list, and then join these two things together somehow. This similarity is a type of function we call a right fold, as it seems to move rightwards through the list, and using some function folds the list up. This is the definition of a fold shown on screen now. A more general version of this function is the start of the first year course, and something you'll look at heavily using proofs by induction and reason about it mathematically. If you want to have a go, you can try the programs I've shown in this video. You can follow the tutorials on the link I've put on the screen, or you can try to implement your own. However, functional programming is a complex paradigm. Don't worry if it doesn't make sense straight away without someone there to guide you. The most important thing is just to have a go. I hope you've enjoyed the shots of Oxford I've been playing in the background of this video. It's a very special place, and I hope you choose to make an application here. Thank you.